So, like, how many folks here in the room use Kubernetes in production? All right. And how many of you are somehow involved into the security these days, kind of securing applications in Kubernetes? Oh, interesting, right? So, and that's exactly the point. So it's because just your security teams, or whoever is responsible for security in your organization, didn't come to you, haven't come to you yet, because they will, and I can tell you for sure. And we're here actually to talk about the shift we're seeing in how basically security is implemented in Kubernetes, and for you to be prepared to the shift, which is happening, because like we speak with a lot of customers and they say to us, oh, we use Kubernetes, we run our applications, typically security team didn't kind of talk to us, or because like it's normal like for security to be implemented somewhere outside, right? So like our networking team, our security teams, right? So that's traditional way to do things, right? So something around us that implements security and we are good. Yeah, but not anymore, unfortunately, especially when we talk about various environments. So here we're going to talk about how to think about zero trust in Kubernetes, because it's a little bit different than if you heard about zero trust before. By the way, how many of you heard of zero trust before? Okay, good. All right, with that, let's get started. So what we're going to talk about, just a little bit of introduction, but I think we all know about that, how things are moving forward, how they are transforming, what are the security challenges that are associated with that. Give me a second. Yeah, I think I'm going to do that. So what are the security challenges? What zero trust is and why it matters in our current modern environment. And finally, how zero trust applies to Kubernetes and some best practices, how to implement zero trust, so what to think about, what to pay attention to. And finally, some kind of extra links for you to kind of learn more about Kubernetes and zero trust in Kubernetes specifically. With that, I think, yeah, that's, like nice picture, which tells a few simple things. The first one is that in terms of developing applications, like we still have, like a lot of us still have kind of developed monolith applications, and that's fine, they're not going to go anywhere, but we see like a transformation or kind of move toward microservices-based architectures where everything is distributed, loosely coupled, but need to be interconnected and communicate, need to be able to communicate to each other. And this in turn, this move toward microservices drives the need to kind of transform our underlying compute infrastructure, which makes things even more complicated because we're just moving now from kind of server application type of thing to server to virtual machine, and finally to containers. And when we are actually beginning to manage containers at scale, like half of the audience here, we use Kubernetes, right? It's a container orchestration and management at scale. And to add even more complexity to that, so by the way, how many of you have, or you can use any form of cloud, one or multiple clouds to run your workloads? Okay, again, it's kind of about half of the audience. So that's what makes things even more complicated. So there is a move from on-premises to cloud, or let me say in a more kind of common way, it's like a hybrid approach. Some workloads run on-premises, some workloads run in the cloud, and we even see these days like the term that's called cloud repatriation. So like some workloads, kind of companies decide, oh, like, yeah, maybe cloud is good, but yeah, let's move our workloads back to on-prem, right? For example, but cloud is not gonna go anywhere, and these, hybrid, multi-cloud environments will stay, whether it's just simply for kind of failover and availability purposes, or for some other things like being more agile, and but they're not gonna go anywhere. So with that, all these environments create additional kind of issues and challenges in terms of how to secure them. Like in the past, what we had, like we had kind of sort of like castle, and yes, something what is outside the castle is not trusted, but as soon as you get inside the castle, we're good. So I'm gonna show it on the next slide. But when our applications become distributed, and when we don't know actually where they're actually running, just somewhere in the cloud, right? Or some of them on-prem, and how they are interconnected, right? Basically, like the attack vectors and attack surface is dramatically increasing. Basically, how we're gonna protect our applications, because there is no like perimeter as such, right? So we can talk about organizational boundaries, right? But that just sort of, they're not ephemeral, but kind of virtual in terms of physical infrastructure. So how we're gonna do that? At the same time, we see that the number and sophistication of cyber attacks is growing exponentially, and there's a lot of things that might happen and which could lead basically potentially to irreparable consequences to our organizations. Also, because we are talking about hybrid multi-cloud environments, we see that our increasing complexity, like we use different technologies from different cloud vendors. We see different tools like that sometimes might not be actually compatible to each other. So we need to learn all of them, which just doesn't make our lives easier. At the same time, we as developers, right, we wanna, because our core purpose, right? So we wanna deliver applications fast. We wanna deliver them as fast as possible, new features. So basically making business happy, right? So like move business forward. And very often we see that, if someone comes to us and say, oh, yeah, let's kind of implement, extra levels of securities. Oh, it's another process, right? Or another thing we need to do. But and we see that like basically as a barrier to our development capabilities. So, and I'll try to show that everybody can coexist, right, and live in the kind of beautiful world, because like with the proper tools and proper methodologies, so we can achieve that. And finally, many industry and governmental regulations exist that put stringent security requirements, how you handle sensitive data. And if you do not comply with these specific, with these requirements, right, or your company does not comply, you might be in trouble. So with all these things, what would be the answer? The answer would be zero trust. Like, because application architecture is evolving, and because distributed environments are very hard to secure, and because of the number and sophistication of cyber attacks is growing, there are multiple ways, and some of them were already mentioned here. We, again, as I mentioned before, we cannot live in the castle anymore. So we have to deal with these distributed and loosely coupled environment. So, and what would be the answer to that? The answer would be zero trust. And zero trust basically means three simple things. Never trust, because like in the previous approach, like as far as you are inside the castle, right? So you sort of like trust it, right? So because you passed all this authentication stuff and you're good. Not anymore. Never trust. Second one, always verify. So whatever request is being done, or something action is going to happen with the system, always verify. And finally, of course, continuously monitor. So no security exists without monitoring, auditing, tracing, logging. So it's just what's going on and how to visually represent that, or just how to handle security incidents and stuff like that. So basically, zero trust is the answer to the question how I can secure my distributed environment from the growing number and sophistication of cyber attacks. So what is Zero Trust? So unlike a perimeter-based security model, Zero Trust is a so-called identity-based security model, which means every single element of the infrastructure that perform kind of interactions with ours or communicate with ours is issued an identity, whether it's user, device, or service, or application, right? So identities. And everything is based on identities, basically who you are. Like, if you go to the airport, right, we'll be for sure checked for our IDs, right, before we'll be able to kind of get into the gates. And they will be kind of checking our tickets, but, a bit later about that. And in terms of what does it mean for Zero Trust, how it's implemented, these three principles: never trust, always verify, and continuously monitor. It's first thing, like every single entity, as I mentioned, must be explicitly authenticated and authorized. Again, just think about when we travel by air, right? So we come into the airport, and our identities are always checked, like at the security checkpoint or sometimes at the check-in desk, or even at the gate sometimes, if we fly internationally. Second one is authentication and authorization, whatever it is, basically certain things that we are allowed to do. It's temporary, so it's limited in time. It's like, again, we bought our tickets to the plane, right? And it's limited, right? So you can use it only to fly to a specific destination, right? So and you cannot reuse it anymore. So that's another thing. Everything must be kept confidential. So all communications must be encrypted, and all parties must be again authenticated. So basically, an integrity must be maintained. So like, yeah, I'm really the party who is actually claimed to be. Also, the access must be given on a least privilege access on a least privilege basis. Basically, only allow things that needs to be done by the specific person. So basically, the common approach is deny all, right? And then just start kind of opening things for those who needs to do very specific things. And when we talk about Zero Trust, just think about just assume, right? So like Zero Trust means that you are able to mitigate all kinds of attacks, and just assume that the attacker is kind of inside, but inside is literally kind of what is inside, right? So it's basically the attack is already in place, whether it's kind of originated from internal users or external users. How would you deal with that? And in order to implement Zero Trust, Zero Trust introduces a couple of concepts, a few concepts, core of them being so-called policy decision points and policy enforcement points. Basically, policy decision point is responsible for basically making decision whether to allow things to happen or not allow, kind of control point. And policy decision point is actually thing that just consult with policy. Policy enforcement point is the thing that consult with policy decision point and basically perform that action actually. Like for example, again, if you are going, if we are at the airport and you are trying to kind of use your boarding pass to go to another gate and board another plane, so policy decision point would be that system that would check your boarding pass, and the attendant at desk, they will basically just deny boarding to you. And that's going to be policy enforcement point. And that's the way we think about Zero Trust. Just kind of imagine that. These policy decision enforcement points, they are responsible for authentication, authorization, access control, encryption, security policy, and auditing, monitoring, logging, all these things. So with that, so let's see how these architecture applies to Kubernetes. So we know like we have Kubernetes clusters, we have services running in Kubernetes, and the key thing here is to think about whenever you apply any policy, right? So just start thinking from what is the scope of this policy first. Because sometimes, like, you know, I can give you an example. Like in the majority of cases, like if I say zero trust in Kubernetes, how many of you actually will think about service mesh straight away? Just raise your hands. Oh, not a lot. That's good. That is good, because you know service mesh might not be needed, for example, to implement zero trust for your particular infrastructure. So the point here is that first thing to think about the scope of what you want to protect. So if you have, depending on your infrastructure, if you have like one application per cluster, right, and you want to protect that application, so you probably don't need to implement service mesh because you have a single entry point, or you have a control at the edge of a Kubernetes cluster, which is like ingress controller or ingress gateway. So you can do all your stuff, you can apply all your security policies there, and you don't need to go any further. You don't need to go to the granular kind of application level. However, if you have like multiple applications or multiple services, and but these still kind of multiple applications, they kind of unified with the same security policy. Again, no need to do these granular things. However, if we are starting to talk about services that communicate to each other, there we go. They might be the need for service mesh, because we need to control, you know, how one services interact with other services and what they allow it to do. So in simple ways, in terms of zero trust, so we talked about policy decision points, policy enforcement points. So these kind of ingress controller and service mesh sidecars, you know, I know that there was a talk about kind of sidecar-less service meshes, but you know, like for now, we're just gonna say about kind of sort of like sidecars, whatever it's kind of, it used to implement these utility things. So policy decision, policy enforcement points can be an ingress controller, which controls security for the entire cluster, or potentially, if you know it's one application per cluster, for the entire application, or it can control, you know, service-to-service communications with, in this particular case, service mesh, and then those, you know, entities, elements that's going to be running aside of your application will perform those policy decision points and policy enforcement points functionality. But still, that's going to be the same thing: authentication, authorization, access control, dynamic policy, encryption, auditing, stuff like that. So why I'm talking about ingress control and service meshes here? Because, like, of course, there is always a way for us to implement security within the application itself. But do we really want to do that? It depends. Sometimes we might want to do that, but sometimes it's better for us, so it's not to kind of put additional burden on us to kind of implement or embed security into our applications, to use just platform layer, in this respect, Kubernetes, to implement our security measures. In terms of features and capabilities, I mean, I'm not going to go for kind of every single of those. Again, just a few key things I want to mention kind of globally. So think about how would you authenticate and authorize requests, whether it's just going to be basic or JAD or, you know, OIDC or some integrations with other providers. So first thing is authentication, authorization, the first part of zero trust. So how you authenticate and authorize entities. Then, second going to be data encryption and integrity, which means how you protect transmitted data and how you're making sure that, you know, it's not protected in terms of, not only protected in terms of kind of encryption, but from modification and from authenticity or validity, identity of the parties that communicate to each other. And then the next thing is role-based access control, or just in general access control and access policy. And specifically, I want to mention role-based access control. Like, how many of you heard about gateway API? Not API gateway, but gateway API in Kubernetes. It's a, Okay, good. So the thing here is that, like, typically when we expose applications in Kubernetes, like, we use one of the forms with kind of one of them being ingress controller or ingress resource. But ingress resource by itself doesn't kind of support a lot of use cases, and that's why Kubernetes SIG developed Gateway API. Basically, it's a role-based API and role-based approach to applications, meaning like certain parts of the company can do certain things and can kind of manage the entire infrastructure. But for example, for developers, you know, speaking of a previous speaker, so like we just should put kind of some guardrails perhaps for them to do things that are expected from them to be done and not going beyond their responsibilities or beyond their beyond their scope. And then, of course, monitoring and observability. So this is, again, there are several sessions already on that. So the key thing, when you implement security, right? So you have to monitor, you know, what's happening, right? So whether it's just real-time metrics, historical metrics, you can collect data, analyze data, you know, make certain informed decisions based on that data. And finally, sometimes it's even necessary to implement so what we talked about is pretty much general things, so, but sometimes it's really necessary to implement protection at the even kind of application layers. Just implement web application firewall or denial of service protection to, for example, mitigate OWASP top 10 attacks. So, and the thing here is that everything that you do, ideally, should not be kind of, I would say that, shouldn't be intrusive, right? It should be as transparent as possible. And in order to do that, so let me do this. So I'm going to do it to that. I go, like, what are the best practices, right? So how would you implement that? So avoid adding complexity or extra complexity for the developers and for users. And that means if you use, like, for example, ingress controller to provide access to your applications in Kubernetes, right? Look at it, and, you know, does it have sufficient features and capabilities to implement your security? So to implement basically zero trust in terms of managing traffic from and to the users to the application within Kubernetes. So, like, that's the first thing. So make sure that, or try to leverage the same tools that you use for other functions to implement zero trust security. And especially when we talk about hybrid and multi-cloud environments. So these tools ideally should not be tied to a specific cloud. They should be infrastructure agnostic. That will make sure that you reduce tool sprawl and reduce complexity, and you don't have to kind of learn different tools. You just have one set of tools that implement or kind of solve pretty much all your problems. If you implement zero trust, make sure that, depending again on your architecture, you might want to implement only north-south, because if you don't have communications inside the cluster, or if you have communications inside the cluster, make sure that you do both. So you do north-south, so-called, and east-west, basically communications to and from the cluster and communications within the cluster. If you need to secure cluster, so think of ingress controller first, because that's what I started with. What's the scope of this policy? Because typically ingress controller sits at the edge of a Kubernetes cluster and controls whatever is, you know, incoming and outgoing into the cluster. I mean, incoming and outgoing from the cluster. And if you need to secure service-to-service traffic, yes, use service mesh. And ideally, if you need to use both, integrate ingress controller with service mesh. And by integration, this could be many different things. One of them being maybe look at using the same data plane for both of those, ingress controller and service mesh. It could be make sure that the method of configuring it the same, or at least similar, familiar, or it could be just like, for example, implementing automated certificate management is one of the key things for zero trust, as shown in the fifth bullet. So they use kind of the same way, and support the same features and kind of mechanisms to do this automated certificate management, because it will make your lives easier, or kind of platform teams' lives easier. And at the end, so I'm going to do this. So implementing Zero Trust for Kubernetes is not a tough task if you do it using this approach that I just kind of outlined, just very, very high level. Protect an application from edge to cloud with stringent security controls, unauthorized activity by blocking on all prevent unauthorized activity from blocking all communications that are not properly authenticated and authorized. You are minimizing attack surface with access control, ensuring holistic app security potentially by adding web application firewall, basically layer 7 application protection, and gaining better visibility into your infrastructure with advanced tools, and finally, using the same tools across all environments. You help reduce complexity and tools sprawl, making your lives and lives of your teams easier. So finally, if you want to learn more, I think these will be distributed to you in the form of PDFs. So if you want to learn more about Zero Trust in Kubernetes, O'Reilly Media published an ebook that you can, if you have a subscription, you can just download it and read it on Zero Trust in Kubernetes. Or you can just go to our nginx.com website and get it as a complement from Nginx. Also, if you want to learn more about like how Zero Trust might look like, feel free to visit our demo, like how to do Zero Trust in kind of 4 minutes. And finally, if you have any questions about Nginx, just if you are not yet, join our Nginx community. It's nginxcommunity.slack.com. Just register and just you can ask any questions in there. So yeah, I think I'm kind of on time. So if you have any questions, I'm still hanging around here. So just we'll be happy to answer them. And thank you.